What's up, guys? It's us, Eric and Henry, the Cheese Curd guys, and welcome back to another video
where today we're going to be explaining physics to dummies like this guy.
Hey!
Cheese, it tastes so good to me. Cheese, it tastes so...
So, Garrick, what is a physic?
No, not a physics.
Oh, physics.
No, physics.
Oh, right. I knew that.
Gee, I think I found the dummy. Anyway, physics is a science that deals with interactions between matter and energy. In layman's terms, which are demonstrably sorely needed for the layman saying to my right, is the science of motion.
Right. And for our first physics topic, we will discuss... motion is when stuff moves. What? Is it not?
Yes, but that's an oversimplification. Motion can be demonstrated through several different equations. One aspect of motion is position.
That's where stuff is, right?
Yes, in relation to other objects, basically a change in object's position. Position can be modeled by this equation: change in position is equal to the final position minus the initial position. The x can also be y for vertical motion. This is the mathematical way to explain motion.
Another way is the graphical method. Behold, a motion graph. And finally, there's the narrative method. Behold, motion. Let's say that this ball rolled 10 meters in about 5 seconds, and the ball had an initial position of 0 meters. Let's say that's the origin, and a final position of 10 meters, and moved at negative 2 meters per second. Seeing as velocity is the change in position divided by the time, which is negative 10 meters divided by the seconds.
To elaborate, since it moved to the left, its position is negative 10 meters.
Why is that?
Well, if an object moves away from the origin to the right or up, its change in position is positive. Meanwhile, if an object moves towards the origin to the left or down, its change is negative.
But isn't there more to motion?
Sure, there's also distance, represented by this symbol. It tells how far something travels.
So the ball's distance is negative 10 meters?
No, you idiot. See those absolute value lines? That means it cannot be negative.
Oh, right. I knew that.
There are also vectors, which have a direction and number associated with them, so they can be positive or negative, like velocity or acceleration. And the scalar quantities, which only have a number associated with them, like no direction, like distance or mass.
You mean vector? Like, I'm committing crimes. Both direction.
Oh no.
And?
Please shut up.
Magnitude! Oh yeah!
To conclude, the motion sector is negative velocity and speed.
That's how fast you are, right?
Yeah, that's actually correct. Speed is scalar, so it's always positive, but velocity is a vector, so it can be positive or negative. It can be modeled with this formula. Next, we'll be discussing forces.
You mean the stuff with the apple guy?
You know what? Sure. And that apple guy's name is Isaac Newton, and he was actually integral to... Never mind, but that guy's work is what we'll be discussing in. He made several laws of motion, first of which is that objects in motion, or at rest, will stay there until acted upon by net force, which is the sum of all things on an object. If there's no net force, the object will not change its state of motion. Newton will also remember that mass determines a resistance to motion. Next is Newton's second law of motion.
The boring one?
The boring one. It states that acceleration is directly proportional to forces and inversely proportional to mass.
And then the third law?
And then the third law. Every force, there's a narrow and equal magnitude in opposite direction. For example, if I have a cube and I'm pushing it to the left, both forces are counteracting each other. So our next topic is energy.
So, like the stuff that makes you move.
Yes, but let's go deeper than that. Energy can go into two different types, kinetic and potential. Kinetic is when you're actively moving, while potential is when you're not moving, but you have all that energy built up.
So, when I take my daily walk, I've been using kinetic energy all this time?
Indeed, there's also different types of kinetic and potential energy.
Is this just one big rabbit hole?
Yes, it is. The different types of kinetic are energy, electrical, thermal, radiant, sound, and nuclear. It can be modeled like this. There's also different forms of potential energy, such as chemical bonds and elastic and gravity. Here's the formula. To give an example, let's say a ball was held at rest on the top of a hill. It provides the maximum gravitation potential. As it rolls down the hill, it speeds up with its potential energy being converted to kinetic energy. At the bottom, the potential energy is 0 and the kinetic energy is at its maximum. Y equals 0.1x squared plus 10 can be modeled with the potential energy, while y equals 0.1 squared x squared can be modeled the kinetic energy. Meanwhile, the total energy is y equals 10 because it never increases or decreases because energy cannot be created nor destroyed, only move from one to another.
Cool.
Next week.
But before we get into that garbage, let's talk about today's sponsor.
What?
Raid Shadow Legends.
This was in
Raid Shadow Legends is one of the biggest free-to-play, online, massive, immersive role-playing games on the market right now. And it's totally free. Since 2019, Raid Shadow Legends has enthralled players with an amazing storyline, awesome 3D graphics, giant boss fights, PvP battles, and hundreds of never-before-seen champions to collect and customize.
Are we getting paid for
So
that?
go ahead and check out the video description in the description section to get 50,000 silver immediately and a free epic level champion today. Now, back to the video.
How, why, what? Never mind. Anyway, the next topic we'll be covering is momentum is the tendency for an object to keep moving after a force is applied. It can be modeled with this formula, which P represents the momentum of an object. Furthermore, when the momentum of an object is ever to change, it's called impulse, which can be modeled by multiplying the force at a time of the object or by subtracting the initial velocity from the final velocity. As a general basic rule, object with more momentum requires a higher impulse to stop, and it can be increased by having more force or time. Additionally, you haven't interrupted me in a while.
Yeah, that sponsor kind of wore me out. Besides, there's a bug on the ground.
Cool. Alright, additionally, momentum cannot be created nor destroyed. The total momentum before and after collisions will always stay the same, even if it's transferred from one object to another. Speaking of collisions.
Aw.
What?
It died.
Anyway, the collisions are when the objects crash into each other. There's two types of collisions: elastic, which objects bounce off each other, and inelastic, when objects do not move far away from each other after the collision.
Like this.
Don't do that. That can be quite annoying at times. You know what? Nothing less. You showed the camera as the example of an inelastic collision. Let's say the camera was 0.5 kilograms and about 1 meter off the ground. The velocity would be about 4.4 meters per second. This means the momentum was 0.5 times 4.4 meters per second, making it 2.2 kilograms meters per second.
Wow!
And finally, rotation.
Ninja go! Spinjitzu.
Before we get into that, we have to discuss displacement, which is two forms, linear and angular. Linear displacement is when an object changes positions in a straight line, measured in meters or another form of distance, while angular displacement is circular and measured in degrees or radians. There's rather 360 degrees or 2 pi radians.
Pi.
Right, thank you. 2 pi radians in a circle so each turn is about 6.28 radians of angular displacement. In arc length, what is the pathway along the circumference of the circle, which is the object travels as it undergoes angular displacement. It's measured in meters or another distance measurement.
The other distance measurements had positive and negative directions. Does this one have those too?
Finally, a sensible question. Yes, they do. Counterclockwise motion is positive and clockwise motion is negative. With like displacement, rotational velocity and acceleration are also linear. Straight lines, distant units, or angular circular measured in time units. These symbols for each respectively are
Theta, which is in radians.
How did you know?
Omega, which is in radians per second.
Are you?
And which is in radians per second squared.
That's actually correct. And using the radius of a spinning object, you can determine the tangential velocity, radius times angular velocity and acceleration, radius times angular acceleration. The forces causing angular acceleration is a torque, which depends on the forces being applied. It can also be multiplied by the radius by the force. If the net torque and the net force is zero for object, it has an equilibrium if we can find the object is in dynamic equilibrium at the forces of all at the sum of all forces and at the sum of all torque, and see if they're equilibrium.
Man, this is pretty complicated. Is there a way to simplify it all?
Well, to tell you the truth, no, but the simplest form of rotational motion is called uniform circular motion. Uniform means at constant speed, and circular being pretty obvious.
So it's motion in a circle at a constant speed. Like when I put kindergartners on the merry-go-round at the playground and spin them until they vomit purple through their noses?
Well, yes, but no. What are you talking about?
Never mind.
Right, there's a few kinematics used for UCM. There's period at the time for one revolution, frequency the number of revolutions per second, angular position the angular traveled relative to the starting point, arc length the distance between the arc length traveled and radians, the angle traveled and the units for angles. Velocity in UCM is targeted and acceleration is radical, by the way.
Silence. I've had enough of your self-importance. I shall finish this.
What?
Shh! Now, according to Newton's second law, all accelerations are caused by a net force that is parallel to the acceleration in the event of a circular motion. This net force is located at the center, so it's called centripetal, meaning center-seeking force. Yes. Centripetal acceleration can be calculated by dividing the velocity times the radius of the object, and centripetal velocity can be calculated by dividing 2 pi times the radius of the period. By the period. The final part of physics that we will discuss is mass and moment of inertia. Inertia is an object's ability to resist acceleration, so the moment of inertia is the object's ability to resist angular acceleration, which depends on the mass and shape of the rotating object. More moment of inertia means more rotational kinetic energy, less linear energy. More angular momentum and more torque is needed to accelerate the spin of the object. Anyway, guys, that will be all for today. Thanks for watching.
Don't forget to smash that like button and absolutely demolish that subscribe button to stay updated for future uploads that won't happen.
And we will see you all next time.
Goodbye.